I mentioned earlier that electrons have their own physics to describe them, known as quantum mechanics. When electrons were first discovered in the early 1900s, physicists were just blown away by its properties because it didn't follow the physics that physicists had been using for centuries. So one of the unusual features of an electron is sometimes it behaves like a particle, which has a certain set of physics, and then sometimes it acts as a wave, which has another set of physics. So quantum mechanics kind of melds those two together so we can have a better understanding of how electrons work and how to predict their properties. Now, for our purposes, how does that impact us? We're not going to go into too much detail, but when we talk about shells, where electrons are, it's not 100% accurate because electrons actually don't have a specific location at a specific time. They have rather what we call probabilities. And sort of weird because if we have a particle like here I am sitting in this chair, I know I'm here. I could use a GPS to describe where I am. Not so much with electrons. But we do know with 90% probability where they're going to be. And this slide here shows the statistical workup of electron density. And the places, these densities where they're localized are also specific energy levels known as orbitals. And you may take another chemistry class where you look at that in more detail. But for us, what we want to consider is that the shell is an oversimplification. It works for this level of chemistry, but if you go into any further chemistry class, you'll probably look into more detail at the quantum mechanic model, or at least parts of it.